Hello. So today we will be solving the question from Codeforces contest. That is 995 division 3. That is the question name is the counting pairs. The D question. Let's first understand the question. So the question is telling us that you are given a sequence A consisting of n integers where the ith element of the sequence is ai. You are also given two integers x and y. Okay, and the condition is y is greater than or equal to x. Okay, now a pair of integers is considered interesting if the following conditions are met. One is less than or equal to I and j, means I and j means j is greater than I. Okay, and if you simultaneously remove the elements at positions I and j from the sequence A, the sum of the remaining elements is at least x and at most y. Okay, and your task is to determine the number of interesting pairs of integers for the given sequence of A. Okay, so let's understand with some example. So let's say we have x equals 8, y equals 10, and our array of, so our first example, that is 4 6 3 6. Okay, so it's 4 6 3 6, right? This is our array. Now you have to find such pairs, such I and j pairs, such a way if, please understand, so what is the total sum? Find it. So it is actually it is 19. Okay, the sum is 19, and from that 19 the I and j element are removed, means ai minus aj. Okay, so this whole thing should be at most y, means less than or equal to y and less than or equal to x. Understood? Means the sum of whole array sum minus a of I minus a of j should be less than or equal to y and should be less than or equal to x. So this is what the question is trying to find, these pairs which are satisfying these conditions, right? Let's see something with the example that we have. So it was what? It was 4 6 3 6, right? It was 4. Our x is what? 8. Our x is 8 and y is 10. Okay, now see, so what is my brute force approach, or what is my thinking? Simply I would iterate through all the elements. Okay, obviously I cannot be j, so I would start my j from here, let's say, first of all. So I will start from j here, and I will find all the I backward traversing, right, such that it are satisfying my sum, which can be easily find sum minus, so from here the sum is what? Sum is 19 minus 6 minus your a of I. Okay, minus a of I is it greater than less than or equal to 10, and it is 8. We would just check with the if condition from all the behind elements and you get your answer. Means here, as we can see, let's check for j6 and for I4. Okay, so 19 minus 6 minus 4, it's 9. So is 8 less than 9? Yes, it's satisfied. So we got one pair, that was 4 and 6. In the Codeforces website, it is actually showed about I and j 1 2, right? 1 2 indexes. Okay, another, let's take our j here and let's check for the 6 and 4, right? This is our approach. Means 8, is it 19 minus 3 minus 6? Yeah, okay, so is that okay? So it is 8 less than or equal to 10, less than or equal to 10. Yes, it is satisfied. Okay, so means this is also a valid pair, that is 6 comma 3. Let's check for 4 comma 3. Okay, so what is the value? 19 minus 3, that is fixed, that is 16 minus 4, it's what? It's 12. It's 12. Okay, so because it's 12, this is not valid pair. We move j here, we iterate through all the i's. Okay, see, one thing to note here, is 6 3 valid? Okay, 6 3 was valid. So is 3 6 valid? Means my I is at 3 and 6. Obviously we are just carrying for the sum. Our main condition was a of I minus a of j. Means if this a of j comes here and a of I goes there, there is no issue, right? Means so 3 comma 6 is also a valid pair. Similarly we saw, okay, so 4 comma 6 is also valid pair. So that's why this all valid pairs we get a answer, means the answer is 4. Okay, so in this simple if else condition, our time complexity goes to O of n square, which we want to remove. Okay, now how we will approach? So see, we have 4 6 3 6, we have 4 6 3 6. See, let's say I am at this position. I'm at this position. Okay. Now, what I know something for sure. See what? See, I know some, that is 19 minus 3. I can also do, that is 16. Okay. Minus a of I, right, is less than or equal to what? 10 and less than or equal to 8. Right. Let's do minus 16 both the way, or just minus it, means minus a less than or equal to okay, sorry. So if you see, let's add minus 16. So it is like minus a less than or equal to minus a of I less than or equal to minus 6. Multiply both sides, minus a of I less than or equal to 6. Here we got the range of a of I. What can be actually a of I? That is for sure between the ranges of 8 and 6. This is an important thing to see, and from this you get how to solve this question. So here, this is valid pair. Let's say I was at 6, my j was at 6, so 19 minus 6, 13. 13 minus a of I and less than or equal to 10. You know about x and y, 8, and minus 13, that is minus 5, minus a of I minus 10. Oh, sorry, it's minus 13, so it's minus 3. So my a of I range is fixed. It should be less than or equal to 5, less than or equal to 3, right? It's plus 3. Okay, so I know at the back that my range is what? My range is what? See, now see one thing for sure. One thing for sure. If 4 6 4 6 3 6, I am at this position. Okay, I know my a of I should be between what? 3 and 5, right? What if this whole part was sorted? Let's say it was 3, 4, and 6, right? 3, 4, 6. Through, I could find a lower bound approach. Let's say in some test cases there may be elements such as 2, 1. Let's say, suppose we have such elements, right? Through binary search, if this bag was sorted, if this whole bag, the all was sorted, okay, through binary search, I can get this point, and I can get what? This point, this or this point, okay? Means upper bound of 5 and lower bound of 3. And I could get how many elements are there here. Means this is not valid actually, so this is my answer too. Yes, so is there any data structure to have a like sorted thing? Yes, there is a multi-set. Multi-set is there which maintains everything in sorted order, but multi-set don't have features to get your length. Okay, so if there was thing 1 2 3, let's say 3 4 and 5, and if we want the range between 3 and 5, let's say your bound of 3 will point here and upper bound of 5 will point here, but it will not help to find the distance between them. In multiset, it's not possible. For this, we need to use a new data structure, that is PBDS, policy based data structure. That is ordered set. Okay, so this is ordered set, and this is the data type which you will take care, and this is constrained, means should it have all less, means should it have this type of thing 1 2 3, or it can have thing 1 3 3 3 4, like that. Less or equal means it can have equal elements also. If you know that sure it has all the different elements, so you can remove this. Okay, fine. So this is how, and you need to use its function. So it's simple. You need to define order set in the same way as you did for set. So order set, you can do an S. This is how, and you need to use the function, that is order of key. So S dot order of key, which will give you the element that are less than, strictly less than k in log n. So in our case, in this thing, if we write order of key, let's say I write 3, so I get this 2 elements. Let's suppose we have this 1 and 2. Okay, it can have, I'm taking an example, and if I do what? Order of key, okay, so it's in short form, okay of, as I need to find my 5, I would write strictly less than 5 plus 1, okay, because I need 5 also. In this 3, I'm fine. I will remove that. Okay, so order of key of 5. So I would get this 4 elements, 4 and this 2, and I will minus this 2 to get 4 minus 2 to get this 2 elements. So what was my approach? 1, 2, 3. Let's say we have this set 4, 5, 6, and I need to find what a of I in some range that was 3 to 5. So I get all the elements that are less than 3, and I get all the elements that are less than 5 plus 1, that is 6. So I get 6, I get 2, this 4. Yes, this is a different set. Before that it was different, but main approach is to get this number of elements, that is 4. So this is how we can solve. Now let's come to the another method. This is our one method, but what if we don't want to write this type of thing? So yes, so for that there is another approach. There is a key observation here. Let's see that key observation through an example. 4, 3. Okay, so what were the elements? 4, 6, 3, 6, 4, 6, 3, 6, 4, 6, 3, 6. Here, see, you were told, okay, I is less than j, but what I told you, that the order of the elements does not matter. If I told you, okay, my friend, order doesn't matter, then you can sort this array also. And if you sort the array 3, 4, 6, and I told you are at this point and I need to find the range between 3 to 5. So in vector, I get here a pointer, I get here a pointer. In vector, please note, in vector, it is possible to find the range, the number of elements between them using lower bound and upper bound. In set, it is not possible, but in vector, it is possible. So if the order does not matter, I could sort it, and then I could iterate it, and I could use my lower bound and upper bound function to find this 3 and 4, and you get your answer. But why? How you are telling, okay, that order does not matter? Let's see why. See, the simplest thing is here is that you were asked what? See, you were asked that if you remove the position, the sum of the remaining elements is at least x. Okay, so we note that, okay, a of I plus a of j. Okay, so I should go there. Okay, here. Okay, here I told you one key observation: x less than or equal to sum minus a of I minus plus a of j. My friend, you can also write this a of j plus a of I. To max, I am showing you that, okay, because of commutative property, I and j order does not matter. It's okay if I goes there and j is here. It's okay. To max, I have proved it, right? Because of this observation. Very important thing. Okay. Now let's see some, okay, how we are, okay, you are saying with max, but how it's okay. So let's see with the example that is there, 4, 6, 3, 6. See, my friends, and that's okay. So we have here a simple array and we have here sorted array. I am taking a small example so that it does not get messy. See here, what were the important pairs? We have this 4 and 6. We have this 4 and 6 here. Okay, we have here this one and this one. Now when you are here, when I'm checking for this 6 and when I am taking it back, I would obviously get this 4 and 6. Here also it's okay, 4 and 6 got. Oh, another pair was this 3 and this 3 and this 6 3 pair. Oh, wow. But even I am checking with this 6 and going at checking it back, I will definitely get this 3. So as you know, as you saw here, 6 3 and 3 6 is fine, you can swap. And this 6, okay, so you got what? 4 6 3 6, again 4 6 3 6. That was same pair here. Okay, so here when you come, when my j comes here, I will definitely get this 4 and 3 6 again and 4 6. Please see this. 3 was further, then 6, but then also this 3 and 6, this 3 checked this 6. But if the 6 go further, this 6 will definitely check this 3 also. Yes, so it's okay if you work on sorted order, and we can use this sorted thing. Okay, so now let's get to the code and solve the question. Okay, so first I will be so in this question also we have another approach, that is of merge sort. Okay, so I will be solving in a different video. Okay, because this video is getting longer. Okay, so this is a simple inputs that I have taken, n, x, y, and this accumulate function helps to get the sum of the whole array. Okay, and we have declared our answer. Always use LL because our constraints of x and y are larger. Here, as we know that x and y are considered larger, so use x and y. Okay, now let's get to the code. Okay, iterate through all the elements. Okay, obviously we will be iterating from I equal to 1. Okay, now LL, so long it is long, it's I have defined as LL is long. Okay, so LL, what is my left range? Okay, left range is that I showed you this thing. I showed you this stuff. I got this 3 and 5. How? Because in this, what I will do, I will find my a of j range. So I will take a of j here, and what I will do is that I will find here. So my a of j goes there and my x comes here, right? So the a of j should be less than or equal to x, right? Understood? So my left range is that tot minus a of I minus x, y, because y is smaller. Okay, and my right means my range a of I minus x. As x is smaller, so in minus it goes at right. So this is the range of the a of I. Okay, sorry, so I would use a of j here to clarify. This left and right are the range of the a of I. Okay, a of I. Okay, this I have got here. This, by seeing this equation you can get that. Okay, now next, what I need to find? I need to find iterator of that. Okay, auto it, or let's say I find the index only. Okay, so left index, it would be what? Lower bound of a dot begin, comma a dot begin plus I, means it's okay. Okay, so my this lower bound should work till here only. Means if I have this array, let's say I am here, okay, let's say I have sorted the array 3 3 4 5 6, I am here. So if I do a lower bound of, let's say 3, let's say we have such thing, upper bound of 3, so it should not go here. Okay, because I am checking behind this pass. Okay, if we do this, and then the iterator may go beyond this, so we have to restrict its range here. Okay, and it's okay if it come here. It's okay to get upper bound till here. Okay, lower bound and upper bound till here. Okay, and what is our element? It is left. Same thing to get the right index. Okay, right index. Okay, and upper bound right. Okay, and you need to minus it with a dot begin to get the index. Okay, and we have to add this answer, that is, okay, so it's r index minus l index. Okay, and to be safe, suppose if our l index goes above r index, so let me safe here and make this ll. Okay, it may not happen, but it's just to take the test case here. Okay, and so we get the answer. When I was solving the code, I got issue because many people will write here -1, but when I write it +i, it actually solved my problem. In -i, there were some cases that were not handling. Okay, it's in upper bound. It may be at the position of the a of j. Fine. So I think this code should work. So let's run it and check if it's having an issue. Okay, so here it's j. Oh, it's failing. I used upper bound, that's why here we don't have to add +1 here. Right is about, okay, it's fine. Okay, we forgot to sort the array. Forgot to sort the array. Sort a dot begin, a dot end. Forgot to sort the array. That's why I think it is issue. Yes. Accumulate, it's fine. If it's not sorted, it will give same answer. Okay, so it's passed. Okay, using PBDS, all is same thing. Just you need to change this thing. I think you can do it in online. You can search how to use it, and I think you will be able, because it's easy, because you have to just minus the count. Okay, so here if I declare here ordered set as, okay, and I need to keep inserting at the back, okay, my a of j, that is my sorted thing, okay, and here s dot order of key, that is right +1 minus s dot order of key left. This would give right answer. Let's run and check. Wait a minute, it will give okay, wait a minute, don't keep it about ll. Let's do it this. It would be given the number of elements, okay, and I need to insert the first element. Let's go with the loop j equal to 0. It's fine. It will give 0 answer then. Yes, it's also passed. Okay, so this is how we can solve using PBDS also. Okay, so if you have any doubts, you can ask in the comment section. Thank you.